All right. In the process of getting the seat fitted and getting the roll bar all made up, I went ahead and made a bending gauge. Now, making the bending gauge is kind of in accordance with what was shown on Justin the Fabricator's YouTube channel, and he does a fabulous job at talking about not only this but how to bend tube and how to build a roll cage. But here we have what is a bending gauge. So it basically allows you to calculate how much tube you need for a given degree. And this is specific to the diameter of the tube and the centerline radius of the bender and even the bender. But what we've got here is the reference mark, and I've cut a mark in here so I can hook my tape measure in there. And before I put it in the tube bender and bent it, I marked off 1, 2, 3, 4, 5, 6 inches all the way up. Then when I put it in the bender, I set the front of the main die right against what was a line. It wasn't cut at the time. And then I took the slack out of it and marked 0 against the follower. And then I bent it 10 degrees and marked it, and bent it another 10 and marked it, and marked it and marked it. And so you can simply enough just say, if I want to do a 40-degree bend, go around to 40, it'll take me a little over 4 inches, including this kind of dead area right here. But I thought, well, I don't necessarily want a whole pile of these bending gauges in the corner, and I also figured that these would rub off eventually, so I'll just throw it in a spreadsheet to save it. But if you have it in a spreadsheet, now you can do something really cool. You can do a line of best fit, and now you don't need these numbers at all. You just apply the calculation, and then since we're in a spreadsheet already, you might as well go ahead and try to calculate the arc length based on the standard arc length formula and see if do you even need to make this bar, or can you just calculate it? Is that good enough? So I'm going to go ahead and show you those numbers and see if physics does indeed still work.
All right, here we are on the computer. I know that people's eyes tend to glaze over when we do math, but we'll try to make it quick and painless, and this may be something you can apply for your own work. So what I've got here is just Google Sheets open. I've got my degrees just typed in 0 to 180. I've got my arc length as measured, so this is just using the tape measure on that bending gauge that I showed you, making sure that 0 is actually the distance of the slop from the beginning of the die until the bend actually starts. So that's why 0 isn't 0, it's about 0.5. And then I just measured these out as close as I could. So what we want to do is we want to figure out an equation so that we don't have to just use these things and kind of interpolate. So how we do that is highlight these columns, and we're going to go ahead and insert a chart. And then we're going to come over and we're going to change the chart type to scatter. And now you get this line. So this goes 0 to 180, but our data only goes up to 90. And that's okay, because the first glance we look at this is that this is linear. So that's what we suspected. It's linear, which is great. That means that we can get a simple equation and we could apply it without too much worry. So how do we get that equation? Well, we come over here to customize, and we go down to series. And the series is the data. And if you scroll down to the bottom of that, you'll see this box for trend line. Now it auto defaults to linear, and you see, in fact, it is linear. So that's great. But what's the equation? So we come down to label and click use equation. Sweet, there's our equation. It's the standard linear equation form. So it's going to tell you for a given degree of bend for this diameter tube with this centerline radius on the JD squared model 32, the slope is 0.0916 times the degree plus 0.523. Now this in theory should be 0.5, but because there's a little bit of noise in the measurement, it's off, but it's only off by a small amount, so it's not a big deal. So great, now that we have this fit and we're very happy with it, we can go ahead and put it in here and calculate what our answers should be. And that'll take out this little bit of noise in this data moving around. So that's what I did here. So in this column, you see the same equation, 0.0916 times B2, which is the degree, plus this little slop at the beginning. And then I expanded it all the way down to 180. And so now you don't need to use these measured values. You can just either use this chart or apply this equation and get the exact, or at least very close to exact number. But do you even need to bend a bending gauge? Can you just calculate it using the arc length formula? And so that's what I wanted to check. So right here, I've calculated theoretical arc length. So I have my 0.5 to begin with, just like before, but then I calculated arc length, which is the degree divided by 360 times 2 times pi times the centerline radius. And in theory, as long as there's no compression or extension of the tube in the die, these numbers should line up identically with these numbers, except they don't. And it starts off fairly small, but when you get to the bottom, it's off by about 7/8. And so let's take a look at what that looks like visually. We'll just highlight the degree and we'll highlight arc length and we'll do another chart real quick. This is more just so it's easier for us to see. And we'll set our chart type to scatter. All right, so our blue dots is our calculated equation, and our red dots is our arc length equation. And so you can see that they're off, and they're off linearly, and they're off slightly. So what does this tell me? Well, it tells me that if everything was perfect and the tube just remained as it were, then for 180 degrees worth of bend, I'd need 17.78 inches of tube. But what I actually only need is 17. So what this is telling me is for, and this is only for this JD squared Model 32, 1 3/4 diameter, 5.5 inch centerline radius, is that the bender is actually stretching the length of the tube slightly as you bend. So you end up needing slightly less tube to make 180 degrees than you would think if you just calculated geometrically. So now what this tells us is, do you need to bend a bending gauge? You don't have to, but it's probably a good idea. But you don't have to keep the bending gauge. You can just mark it down. And if we want to know what any degree angle between 0 and 180, even in theory up to 360 degrees, you can just pop this equation in and it gives you the right answer. So hopefully I didn't lose many of you. If you have any questions about how to do any of this, let me know. It's pretty simple and pretty useful.